Hey, what's up everyone? Welcome to the stream. So, hopefully the stream won't cut out tonight. We have some pretty crazy weather in my neck of the woods here. And we've already lost power once today, so if I do lose power, well, I guess that'll be the end of the stream for tonight. So, last stream, a couple nights ago, I mentioned that I wanted to go back to rendering and just take a look at some of the issues that I think I'm seeing. In fact, I kind of want to double check my assumptions here. So I talked about making sure that we're doing a resolution independent rendering because I had noticed that things didn't look the same on my laptop as they do on the desktop. So I just wanted to go over that code and take a look. So actually, just try to prepare a little bit. I looked quickly at the code, and what I saw and what I had done was that right now we rely on the projection matrix to scale lines in the 256 by 256 grid. So the idea there is, maybe I'll bring up MS Paint here, try and make some kind of terrible picture to show a little bit what I'm thinking. So if we think about the Vectrex, right? The Vectrex basically is a 256 by 256 pixel grid. Can I write here? 256 by 256. So something like this. I don't know why this ended up being orange, but anyway. So and it is a square, of course. That we saw the screen is not actually square, but what I do is, if we look in the code here, we have this on window resize, which gets called every time the screen is resized, or the very first time it gets set, and we get the real window width and real window height, or this is basically the client area into which we are going to be drawing. What I do is I have this function called the get best fit viewport, which basically uses an aspect ratio to try and return, let's say, let me try and draw it as well. Let's say we get our window is some bigger resolution like this. What the get best fit will do is it'll say, well, given that we want this aspect ratio, and this aspect ratio here is close to actually this is the aspect ratio of the overlay, so not quite the aspect ratio. So the aspect ratio of the Vectrex screen is 3 to 4. So 3 in height, 3 across and 4 height. The one for the overlay itself is not quite the same. The overlay is not a 3-4. It has its own aspect ratio, which I've computed here based on looking at values for the different overlay sizes. And the idea there is to say, all right, give me back something like here. Let's say this is the best fit overlay given this rectangle for the actual window. So what's going to end up happening is we'll get this here. And it is in this that we will render our overlay at this size, whatever that may be. And what we'll end up with is black here on the sides, right? Now, within there, let me see here. I have a scale factor for this, what I call the CRT width and height. So there's the overlay width and height, and then there's the CRT width and height. And for that, I just basically scale the width and height in here. So we're gonna get some kind of subset of this. And let me just take a look again at these scales. So X is 0.93 and Y is 0.76. So something like 0.93 in terms of X means most of the width, but less of the height. So something like this. Okay. Now, so there I'm computing basically the overlay width, CRT width. Here's where I compute the projection matrix, which has nothing to do with these values. And in fact, I could technically only compute this once. There's no real need to do it on window size, but I don't know. I do it here because typically we mess around with our projections here. But in my case, and we may change this, but right now what I'm doing is it's always a orthographic projection that is based on the 256 here by 256. So these guys are, there you see, there's the width and height. The only reason I divide by 2 is that we want to define the orthographic projection in such a way that we are saying that the center here, or I'll take black, you know, the center is 0, 0. Right? And we're going to get like, you know, minus 128 to 128 and minus 128 to 128 for x and y, because this would be, you basically give it the left, right, bottom, and top. And what that does is that means that when I render lines, if I give coordinates in that space, so let me maybe write something here. So this would be like, you know, minus 128. Yeah. Or I'll do like this. Inside. So if we draw, let's say, a line in here, this line will be represented in this coordinate space. You know, so this will have something like, you know, minus 100. Yeah, I'll actually write it down. Black. Say minus 100 to, I don't know, what could that be, like 50 or something. And then this here, this would be like positive 100, maybe, I don't know, 20. So, oh. So something like this. And so by making the orthographic projection work this way, I can just render my lines exactly in this space, and they'll be correctly projected or scaled orthographically to whatever the viewport is, whatever the viewport is set to, which, you know, makes sense, right? And what it means is that over here, where the only place where I actually use these matrices, in fact, this model view matrix could totally be removed. I don't even use it at all. Yeah, I'll probably delete it. I kept these things around in case I wanted to do some interesting transformations, but there really won't be any. So the model view projection here is really just going to be the projection matrix, and we pass that into our shader here as the MVP. And that's the only place where it's used. And if we look in our draw vectors vertex shader, there's MVP, there's our uniform, and we use it to basically output positions of the vertex in clip space. So we take all the vertices that we pass in and we basically multiply them. We transform them by this projection matrix. So that does exactly what we want. It'll, you know, take this and it'll put it into clip space, which is what's expected by the vertex shader here. And then that gets passed on to the fragment shader, and, you know, everything works as expected. So what? So this means that this part will be scaled. Why is it a different color? So I'll choose I don't know, purple. It'll be like scaled this way, you know, projected this way. Right, so then this line here will end up, you know, looking a little bit bigger and looking something like that. So that's what we've got going right now. And one of the things is that I wonder about, what I was worried about, and I want to just kind of double check my theory here is, we are using when we draw, we're using GL lines here. So this is basically, am I looking at the right thing? Yeah. So the draw vectors pass is where we draw our vectors. We are using GL lines or GL points to do the actual drawing. We actually pass in which mode. So mode 1 should be GL lines. Oh, hey Steven, how's it going? So yeah, basically mode 1 will be GL lines here. And yeah, pretty good. You were just browsing on Twitch? So yeah, basically I'm gonna do this, take the MVP, pass it in, and then we're gonna draw. And when we draw our vertices here, we pass in that mode. And then that's the mode that we pass to GL draw arrays. And the question that I have here is, will the lines that get drawn, like at which point are they drawn? Are they drawn and scaled up accordingly? Like would they be drawn in, let's say, in the space of the, this square here, and then when brought to here, they would actually end up thicker? So I guess I should show this one a little bit thicker here. It's not quite accurate. Like if I'll take this color again. Would it be more something like this, but like doubled in size, let's say, or whatever, scaled a little bit? Is this what we're getting? And I don't think that's what we're getting. I think that what's happening is that in the larger space, we're still drawing a thin line. That's what I believe I've been noticing. And I'm going to try and test that theory. And I'll do that by, I'll try something. I have this file where I can set the initial size. Hold on. Here, window. Doing the rounds and notice I was on. Oh, that's cool. So if I was to render this at 256 by 256 exactly, what would it look like? I mean, it'll probably look pretty terrible. But I'm just curious. Oh, and actually, before I do that, let me turn off some stuff. Let's turn off, we'll go to the drawing here. Let's like kind of just isolate and just have lines. So when we render our scene here, I just want to render, where is it? So we know we're going to go through here. Let's not do the darken pass at all. Let's disable blur. Oh no, actually, I do need to do the darken pass. That's fine. It's blur that I don't want. Okay, let's try it this way. Oh, and let me also remove the overlay. Overlay texture. Let me see, how do I disable my overlay again? I don't even remember. I guess create empty overlay. If we fail, reset overlay. I think we just don't call. I'm confused by my own code here. Who calls reset overlay? Oh, it's here, okay. Okay. All right, what we'll do we'll just do that. All right, there we go. Try to take a screenshot of this. Maybe not in Paint here. Just checking here. So this screenshot is 139 by 197. That's not 256 by 256, though, is it? Oh no, okay, sorry, it's because I didn't take the entire size of this thing here. Alt, was it Alt print screen or something? Okay, so 258 by 288, that makes more sense. Okay, so here we can see clearly that lines are 1 pixel wide. Now let's double it. Let's double the size in our options. Yeah, and I think we can already see it, the problem. So 514 like that. Let's zoom in. And here too, you see, the lines are just 1 pixel wide. So I have the two cases here. Oh, I guess I moved this. There we go. So this is half the resolution, this is double the resolution, but this one still has single pixel wide lines. And so that's my problem right now. So using the projection matrix isn't doing what I want because I'm using GL lines. Okay, so let's try another test. So I have a different way to render lines. It's what I call the thick lines render method, and it's something that I actually use for doing my glow texture. But I think if we use, so the way the thick textures thing works is that rather than using GL lines, we actually use we actually render quads. Hey Lisp Gamer. Yeah, I mentioned that at the beginning of my stream that the weather is so bad that we lost power at our house today, and if my stream suddenly cuts out, you can assume that I've lost power again. And yeah, I probably won't come back. So if I magically disappear, you'll know why. So okay, so let's see. Render scene here. Yeah, this thick baselines option that I have. So let me just go over this code again just to like refresh my memory. So let's say if we don't use that, then I have this GL triangles here. You didn't lose power yet, or at all? Let's hope it stays that way. The storm's pretty bad on the East Coast, eh? So yeah, you're smart with your UPS. I totally should invest in a UPS. Alright, so here what I'm doing is I'm using GL triangles, and I'm instead building a quad vertex array. Let's just refresh my memory. What am I doing here again? I'm passing in a line width, which is 0.75. So I divide that by 2 for the half line width here, and then I basically build quads based on that. So technically speaking, I think when I worked on this, I had tried 0.5, thinking that, oh no, actually, why 0.75? Why wouldn't 1 work? We'll mess around with this a little bit. So let's say we were to try just 1.0 here. We'll force this to happen. We'll go through here, and basically we're building a bunch of quads. So yeah, let's just see what this looks like at 256 by 256. Yeah, I see we're actually even missing lines. But if I just want to take a print screen of this. Where's my paint.net here? Just close some of these. Okay. Yeah, so it's curious, right? Like there's some similarities between at 256 by 256, the way Vectrex gets written, where I use GL lines versus my quads here, where it looks like I'm missing entire lines here. Now, part of this is due to nearest neighbor interpolation. I realize that now, because there's an important detail that I'm not mentioning. The important detail is that when we draw, we have this game screen to CRT texture pass, where we do that scaling down that I was talking about earlier. So actually, you know what? Let me remove that scaling just to get that out of the equation. Let's make the scale 1 here, the CRT scale here, just to get rid of any artifacts due to to nearest neighbor interpolation. Ah, there we go. So that's more what we expect. So function alt print screen. Okay, so that's, see, this makes sense. So now let's try and double the resolution again and see if this ends up being scaled. And it does not look like it. Function alt print screen. Copy to clipboard. Yeah, that's still 1 pixel wide. Okay, so basically, what does that mean? This means I'm not sure I understand. Function alt print screen. Oh, here it's scaled. Interesting. I'm not sure I understand. So 256 by 256, single pixel width, but 512 by 512, also 1 pixel in width. It should have doubled this. And then when we go to 1024, which is now 4 times the size. 1, 2, 3. I guess this is like sub-pixel artifacts here. Like this is 4 times the size, but we get a 3 pixel width on the quad here. So here probably would have been double, but you know, we're like it must be like we're so close to 1 to we're not quite at 2.0 somehow. What do you call that? Like I could probably make this work by just bumping up the scale just a little bit. Let me see. For the width of my rectangles, instead of 1.0, if I put like 1.1, then I'll probably get what I want. Let's see. So let's go to 256 by 256 again, just to start as our base here. Okay, so we should still be at 1 pixel here, and we are. Oops, what just happened? Okay, 512 by 512. So did this double yet? I think it did. Yeah, see, there we go. Okay, so we made it over the threshold so that the quads actually took double the amount of space. That's good. And let's try now quadrupling the size, and we should get 4 pixel width. Oh, still got 3. But it's okay. I'm not too concerned. This is just like, you know, minor imprecision issues. Okay, now I feel like going back then to the GL lines and just really making sure, because I want to try and put at quadruple the size and see if we would have gotten any kind of scaling up. So let's put this back to false. So we're back to GL lines, but let's keep it at 1024 by 1024. So 4 times the resolution and see if it looks different. And it does. I mean, I can already tell, right? Function Alt, print screen. So that's interesting, actually. I didn't realize that GL lines work this way. So GL lines is really something that is unaffected by, yeah, there you go. See, it's 1 pixel wide. It's not affected by orthographic projection or any kind of projection scaling. It's something that happens afterwards, and it's as opposed to like you know, when we draw the quads, that gets drawn and then scaled by the projection matrix. Those vertices are scaled, but when we draw lines, it looks like that the driver or whatever is doing the line drawing, you know, after the projection has been applied, if that makes sense. And so that basically means we can't really use lines. We have to do our own lines, which is what the thick lines thing is about. And the thing is, the way I'm doing the thick lines isn't great. The lines are drawn in 2D. Right. So by 2D you just mean like they're drawn into the frame buffer kind of thing, or into the final buffer, as opposed to being drawn in 3D, which means affected by projection. Yeah, without scaling. Yeah. Yeah. Yeah, so what I was going to say is that the only thing that bothers me about the way I'm doing my lines is that there's no kind of smoothing around them. But maybe it's going to look okay. So maybe I don't have to do all that much. Maybe I can just stick to the kind of the thick lines thing that I'm doing. Let's try with that. I'm curious now. Let's say we do thick baselines. Let's enable our blur here. Let's see what this looks like. Yeah, it looks like super thick. Let me just mess around with the blur here, because I think, you know, I'd have to tweak this blur a little bit. See something? I'm just wondering why this is a single line, 1 pixel wide here. I find that rather surprising. Yeah, I just don't get why it would be so thin given that now we're at 4 times the size. Like, what does Polar Rescue look like if we're, you know... I guess we don't even see it. But let me make it a proper 256 just to see. something weird going on. I just don't understand why, like at 4 times the resolution, I'd still end up with these single pixel width lines here on the P. And here you can see that they're also single pixel. Like I'll just draw here. I would really expect all of this to just be scaled up. If it looks like this at 256 by 256, then like if I take this here and I say resize, and I'll put here percentage 400%, right? And I say use nearest neighbor, which is pretty much what I'm doing. 1, 2, 3, 4, right? Like I should expect something like this, but that's not what's happening. I feel like there's something I just don't understand at all. Am I doing something weird here? So I have two bits of code here when I'm building my quad vertex array. So I have a bunch of lines. Those lines would be in the space that I was defining earlier there. The space here, minus 128 to 128 for x, minus 128 to 128 for y. And they remain in that space. But what I'm trying to do here is I'm trying to build 2 lists. One is or 2 vectors really. Oh no, sorry, this is 1. Right, a vector of triangles for quad. So basically 2 triangles per line. Now, what I'm detecting here is if the 2 points that make up the line are nearly the same, well, we'll consider that a point, versus if they are, otherwise they are a line. So I'm wondering if I'm maybe hitting something weird here between these 2 cases. But let's say they are a point here, then what I've done is I have P0 and I have P1. I ignore P1 because they're almost the same, right? Yeah. So I just use P0 and I say, okay, take P0 as the center and let's just make a quad around it, and you know it's not very hard to see, but basically it's 4 corners, right? Using the half, the half width, the half line width here. So we pass in 1, so this will be 0.5, right? So we're saying from like 0.5, 0.5 from the point P0, 0.5 minus 0.5, minus minus, and minus plus. So that's the 4 corners. So we define 4 corners, but then we need to put them as a triangle. So we insert A, B, C, followed by C, D, C, D, A. So those make up our 2 triangles. Yeah, let me make sure that's right again. I know this stream I'm not doing much other than exploring my old code, but I do need to understand this because we have identified a problem. Using GL lines is not doing the right thing for us. It's not going to work correctly at different resolutions, so we have to solve that problem. And right now we are seeing that there's something strange about the way it's scaling up using the orthographic projection. And I mean, maybe the solution here is to fix that. Like that's what I'm trying to do now, or it might just be, you know, forget about using the orthographic projection as we as we defined it, and just make it so that our projection matches exactly the resolution of the screen, and do our own transformations here when we build the lines. You don't take into consideration the direction of the line. So for the point part, I do not, right? But for the line part, I do. Here, with the normal here. So I'm just gonna focus quickly on the point part, just to see if that's what's causing me my problem. So A would be upper right corner, and B would be right down. C is to the bottom left, and then D, of course, is to the top left. And then I'm doing A, B, D, no, A, B, C like this, followed by C, then D, then A to B, B to C. So that's clockwise. Then C, D, and A. C to D, D to A. C, D, and A. Yeah. I mean, this looks alright. Alright, otherwise, let's see what's happening when I draw lines. So what I do here is I take the P1 minus P0, so let's say I'm going to just draw a line here, P0 to P1, and I take the direction vector from P0 to P1, and then I normalize it. So that basically just gives me a normal, just gives me a vector from V to 0, 1 normalized, and then I create a normal out of it by just using the little trick of negating the Y and keeping the X. So that gives me a normal into the line. And then A, B, C, and D would look like the four corners of my quad. So let's see. P0, P1. So I'd say P0 plus N times the half length. So let's say the half length now is 0.5. So we go up here 0.5 from here. And B would be P0 minus N. This is A. So minus N times the half length again. So C is P1 minus, so that gives me C over here, and then D is up here, right? Yeah. And then I say A, B, C again, and then C, D, A again. What does that look like? A to B down to C to the right, and then C to D to A. C to D to A. Yeah, there's nothing wonky in here. Let's debug and see if there's anything weird that shows up. So P0, yeah, everything's been optimized out. Try and disable optimization so I can stay in release here. Okay, so that actually worked. P1. Okay, let me just get myself to that place because here there's just a lot of lines. Okay, so let's say here I have a point, minus 48.82. Yeah. So I guess the issue here is that these lines are very, very, very short. So I'm building up a bunch of very small quads. So that's the issue. Oh, that's interesting. Is that the issue? So yeah, what I'm realizing is, so like the way I build these lines is I do it cycle by cycle on the, and this is something I was already aware of, and I even tried to address this as more of an optimization, but maybe it's going to be more than just an optimization. So basically cycle by cycle in my, now it's been moved to the screen code. We're trying to, detect, like we know when the pen is supposed to, like the beam is supposed to be drawing. And when it is enabled, we take this, the last position, and then we move the beam. And so whatever its last position was to where it currently is, we add a line. But because we're doing it at cycle by cycle, we create many, many, many tiny lines. And when I mean tiny, I mean like sub-pixel, which is what we're seeing here. Because you can see it here, right? Even if the velocity are like integer values, we take the velocity, there's an offset, but let's just say it's 0 there. We take the velocity, these are usually like, I think these are actually integer values. But anyway, let's say it's like moving at a rate of 1. So Lisp Gamer asks, if you go crazy high res, do you see much difference? That's a great question. I'll try that. And can you not draw a line between the points the vector hardware has set on it? Can you not draw a line between the points the vector hardware has set on it? So I think I understand what you're asking. The vector hardware doesn't know, rather than cycle by cycle, no. So yeah, the vector hardware doesn't know about the points, right? All it knows is turn the beam on, turn it off. When it's on, it knows about, it's got integrator values for moving it, which is what you see here. These velocity values are really integrator values. They're like how much to move the beam by, at a certain rate. And here the math is basically, we divide by 128 and we multiply by the cycles, and then that basically gives us, for the current cycle, how much the beam has moved, and obviously that's going to be sub-pixel. Now, what I'm thinking, and I actually had attempted this, and I think I had attempted it, and I think I still have it in Git on a branch. which was I tried to detect, like, you know, as an optimization, not making, you know, so many tiny little lines, but making one line, trying to detect when an actual line was really drawn and when it was done being drawn. Let me see if I can. And so basically the idea there was to coalesce these tiny lines into one. And at the time I was doing it because I was thinking about optimization, and that, like, I was probably drawing way more lines than I needed to, and that this would save me cycles or save me time on the GPU. But actually it turned out not to have almost any effect, really. So I just gave up on it because it complexified the code. But maybe it's more important than I think in terms of getting these lines to look correct. Because, like, drawing thousands and thousands of little quads that together make up a line, what may be happening is these thousands of little quads are being clamped